So this slide has a lot of text, but the idea is simple. It's basically the same thing that we've been talking about. So if you look at the poly function that we had, it's calling pa 2 times. So we have one time argan4 and then one time argan3. But we know that after we are coming back from like calling this one time, we don't know what is gonna be in our arguments. So the only thing that was basically saved was the S registers. So after we come back from this time, the first time that we call the function, we are going to lose A0. And for that, if we want to call this PA again, we don't have the A0. So the way around that is to basically copy A0 to a S register so you can reuse that after. So you see the same concept here. So here we are basically saving everything on the stack. And then the first thing that we are doing, we are making a copy of A0 and putting it into S0. And in that way, when we are calling this function the first time, we know that A0 is already stored in S0 and we can retrieve the value back if we want to. So as simple as that. But for the fact that you're using S0, so this is the important part. If because you're using S0 in your function, you have to basically save its original value on the stack. And then at the end here, you see that we are restoring that original value. So same idea. Basically, to do a recap, we are using A for arguments, V for return values. When you are calling a function and after the function is returned, your values that you had on registers A, T, or V are not guaranteed to be preserved. So you can assume that they're changed. And if you are within the function, so we already said that T is not preserved, but if you are within the function, that means you can use any of these registers because it's not guaranteed to be saved. So you can change any of these if you are within the function, but if you are using a S register, you have to save it on the stack because S are guaranteed to be preserved after the function call. So you save it on the stack and then you restore it before you do the return. So same idea, it is the responsibility of the caller to save A, B, and T if needed. So caller saved. So that means before you call a function, if you need or if you have any value on A, V, or T that you want it to be saved, you have to save it on S or maybe even on the stack. S would be the easiest option. So now on the function part, it's the responsibility of the callee to save and restore S register. So if you are writing a code for the function, it is your responsibility to save any S register that you're going to change. If you are not going to change any register, you shouldn't be worried about it. Like if you are not changing any S register, you shouldn't be worried about it. But if you are changing any S register, then you have to basically save that on a stack. And well, many of these are done by the compiler, but while we are coding in assembly and MIPS, we are manually managing all these details. And that's why it's very important to know what is the mechanism of this function that we are dealing with.